and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to talk about distributions and the normal distribution. You folks are lucky. We have a special guest with us today. He's known as the Sultan of Stats. He's known as the Distribution Diva. He's addition by subtraction. He's Jay Cho.
Hello. Thank
Hello,
you
Jay.
very much
How's
for
it
your
going?
introduction.
You're welcome.
By the way, happy belated birthday.
Oh, thanks. Thank you.
How was it? You have fun?
It's good times, good times.
And how old did you turn?
I just turned 29.
Oh, really?
Yeah.
That's interesting because I'm also 29 years old.
Oh, really? You're also 29.
Exactly.
You know, I think I know a lot of 29-year-olds. I wonder if, there's more 29-year-olds than people of other ages.
Yeah, I think so. However, I think my parents are like in their 60s and 70s.
They're the baby boomer generation?
Right, but they have a lot of friends too, so I don't know. And then how about our students? There are a lot
Yeah,
of kids.
it seems like there's
Yeah.
a lot of people our students' age and a lot of people our parents' age.
Right. So I wonder, how do I know who has which age group has more people in it?
Well, it's funny that you should ask that, Jay, because there's a mathematical object called a distribution that will help us describe, how many people there are of different ages. Why don't you tell the audience about what a distribution is?
Sure. Distribution is just a way to it's like either graph or chart or table. It describes how things are spread out.
Oh.
Right. Just like our age. I want to see which age group is higher, which age group is lower.
Well, luckily for you, I was on the New York Times the other day, and I came across this age distribution graph that I think our students would really enjoy us talking about.
Cool. Let's take a look at it.
All right. So, Jay, when we look at this graph, can you tell me, what's on the horizontal axis there?
Right. It says age. It goes from 0 to 100. So I'm assuming it's like newborn baby to 100 years old. Well, that's pretty old.
Yeah. What about the vertical axis? What is that?
Oh, it says millions. So I'm assuming it's how many people are in each age group. Is that what it is?
How many 29-year-olds like us are there?
It seems like about 4.4-ish.
4.3, 4.4, okay.
Right. That's a lot of 29 years old, more than 4 million.
There is.
Right.
It looks like there's a lot more 23-year-olds than 29-year-olds.
And I noticed that if you look at the millennials, those bars are pretty high. That means there are a lot of people in there.
But when we look at people our age, it looks like there's fewer people. The bars are lower.
I know the Gen X, our group, Gen X, is
those people that are 32 to 49.
Exactly.
Not so many.
Not our age, but people who are older than us, obviously.
Yes, obviously.
Wait, so when exactly was your birthday? I know it was over the weekend.
Yeah, it was on Saturday.
It was Saturday. Huh. My birthday was on Monday.
Your birthday was on Monday?
Yeah.
My birthday's on Saturday. I wonder, do you think that it really, the number of people that are born on Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday, do you think it makes a difference which day you're born, or do you think it's the same number roughly?
I think it should be almost the same, because what's so special about Monday? My birthday is Monday, but why is it different than Tuesday?
Well, I think this is what the situation we're describing is a good example of a uniform distribution. Could you describe to
right? Uniform distribution,
audience?
like a uniform, everything is pretty much exactly the same, and things are pretty evenly distributed.
Oh, okay. So if we look at the graph of the uniform distribution, basically just kind of looks like a horizontal line going across
Right,
it.
it's pretty much just a straight line. There's
and
no up and down. Everything's evenly distributed.
That makes a lot of sense.
Right.
I mean, the word uniform means the same, so you expect those frequencies, the number of people that were born on Monday, Tuesday, Wednesday, Thursday, Friday, to be the same.
Exactly.
Cool.
Exactly.
Jay, I've heard of another very famous type of distribution called a bell curve or something.
Like Taco Bell? Bell curve?
I think it's also called a normal distribution. In all seriousness, can you describe to our audience what this bell curve or normal distribution
Right,
is?
it says bell curve, like a bell as in, it looks kind of like this.
Like Taco Bell?
Taco Bell, sure. So obviously the right in the middle is the average. It's like a mean value.
Oh, okay, so the mean is always in the middle of a normal distribution?
Exactly.
Okay.
And if you kind of look at the graph, you notice that the middle is pretty high, and then as you go away from the mean, it gets pretty low. That means there's not much stuff happening away from the mean.
So you're saying that most of the stuff is sort of clustered around the mean, And then the further away you get from the mean, the fewer, number of people or whatever there are.
Right. I think height is a pretty good example of normal distribution.
Oh, so height is normally distributed?
Right. The average height is 5'10", I believe.
5'10". Yeah, that's about 70 inches.
Right. So most people I know is around 5'10".
Oh, okay.
There are only a few. Think of like friends who are really tall, taller than maybe 6'4", 6'5".
Oh, like my friend Yao Ming, or my friend Andre the Giant.
Sure.
Well,
right.
What about those people that are a little bit shorter? Those people that are like shorter than 5'4".
Oh, like my friend Frodo or Sam.
Oh, you're friends with those guys?
Sure. He took my ring. When is he gonna return it?
Anyways, I heard that there's two real numbers that you care about when you're talking about a normal distribution, and I understand that the mean is a number that tells me like where the middle is.
Exactly.
This other number is standard deviation. How does standard deviation affect our bell curve?
Right. Standard deviation kind of tells you how things are spread out. So if you have a big standard deviation, things are gonna spread out like.
Does that make my bell like fatter or thinner?
It's fatter, more spread out, so it's gonna be like spread out wide.
What about a smaller standard deviation?
That's gonna make the curve narrower.
And what's an example of like something that's normally distributed?
Right. I think the height of men, I believe, is normally distributed with the average 5'10", which is 70 inches.
So if the mean height or the average height is 70 inches, do you know what the standard deviation of male height is?
Standard deviation is 3.
Okay.
So if you look at the distribution of the height of the man, 70 is right in the middle. So that means a lot of people are going to be 70. And standard deviation is 3. So 67 to 73, they're going to be a lot of people.
Oh. Actually, I heard that there's this empirical rule. And I think if you go like a certain number of standard deviations in either direction of the mean,
right,
that tells you how many, like what percentage of the population is that?
Right. So if you go one standard deviation away from the mean,
on either end,
right?
Smaller
so 70 minus 3 and then 70 plus 3. So 67 to 73. They'll capture a lot of 64.5% of the population.
64.5. Are you sure you don't mean about 68% of the population?
I was trying to test you if you're paying attention.
Oh, yeah,
exactly.
You're testing me. I get it.
Excuse me. So that's a lot. That's more than half. It's about 70%.
Yeah.
So think of all your friends, 5'7". It's like pretty much like all of my friends are all along that height.
How tall are you?
5'8", so I'm
not too far
below
from the mean.
average, but I'm close enough. How about you?
I'm around there. Yeah.
What
What about if I'm 2 standard deviations away from the mean? What what percentage of my population is within 2 standard deviations?
Okay, so 2 standard deviation. Each standard deviation is 3, so 2 standard deviation is 6.
Right.
So 70 minus 6 is 64.
Okay.
70 plus 6 is 76. So 64 to 76.
And I heard that 95% of the population is within 2 standard deviations. What about 3 standard deviations on either side?
Wow, that's a lot. 3 standard deviations, so 3 times 3 is 9. So 70 minus 9 is 61.
Yeah.
70 plus 9 is 79.
And
that's pretty much 99, like 99%.
99.7%.
Right, so that's pretty much 100%. So that's pretty much everyone.
Okay. So the empirical rule says within 1 standard deviation of the mean, you have about 68%. Within 2 standard deviations of the mean, you're at about 95%. And within 3 standard deviations of the mean, you're at about 100%.
Right. So if you're outside of those, you're probably an outlier, right? You're either too tall or too short.
Well, you're an outlier, but I guess not in terms of height. This concludes our episode of Slam TV. See you next time.